the impacts of biofuels. And we're 10 years later, and we have produced an enormous amount of literature. So what David and I thought, let's look what the literature is telling us. Let's try to summarize the literature in a more systematic way. Basically, let's use tools that exist right now and try to understand, in a statistical sense, what does the literature tell us. We do need, so meta-analysis basically combines results from different studies in the hope of identifying repeating patterns, disagreements, studying trends. This literature, however, is focused on statistical studies, so we needed to expand it to numerical studies, as most of the studies in biofuels are numerical and trying to assess the impacts. So we expanded this tool to be able to apply it to this question, and then we wanted to understand these criteria and multiple criteria that we have been discussing today, and the literature is very interested, as well as policy and practitioners and others. The literature has been trying to understand the impact of biofuel on greenhouse gases and land use changes. It has been trying to understand, we saw today several papers, it has also been trying to understand food and fuel prices, welfare, impact on employment, and finally I'll conclude. The literature is very thin there on learning by doing, but I'll just give some anecdotal evidence. So starting with greenhouse gases. It depends. It depends very much. We saw Farzar today and Madhu's work, and it depends what you assume. There is a big difference if you want to understand the carbon debt of corn if you start with grassland versus abandoned land. We have also been seeing a very substantial decline in the magnitude of the indirect land use changes from Searchinger to Hertel, no, Farzad and Madhu. So it very much depends, and but when we took the literature as a whole and simply try to calculate the averages, what we did get a decline, the decline of 0.19 kilograms CO2 per liter of corn ethanol. That means that if you start with 3 kilograms of CO2 per liter for gasoline, then you end up with corn ethanol with 281. However, there is a lot of variability. A lot of variability. Some papers will argue for a carbon saving. Some people will argue for a carbon debt. But when we moved on to the statistical analysis, we did Bayesian analysis as well as stepwise regression, and also we did fixed effect. We used various tools, various instruments we created, try to estimate it, and try to see the results more robust. I won't dwell into the details of the models. I'll just try to point out to the highlights that we got in those regressions. Modeling matters, and this is nice to hear for economists, but economics matter actually a lot. We'll start with the greenhouse gases. Models that did the LCA, or the agent models, and did not introduce economic factors resulted in a substantial lower greenhouse gas effect. They lack the rebound effect in this situation. And this result will keep on popping up as we go throughout the various effects. The second effect we wanted to look at is food prices. Again, there's variability across different crops. There's a different impact if you talk about corn versus if you talk about soybean or sugarcane or oilseeds. On average, again, we focus on ethanol, as I should have said it initially, simply because that's where the literature is most abundant. There's a lot of literature focusing on corn ethanol versus the other crops. So it's easier to analyze it when we try to do the meta-analysis. So on average, when you look at corn ethanol, the impact was 24.5%. However, there's a large impact in the short run, pointing to the importance of the transition, or when you have spikes in food prices like in 2007 and 2008. Again, summarizing the results of the regression, we get then introducing oil markets, basically expanding, introducing the energy complex more rigorously will alleviate the effect on prices, simply because of the linkages among markets respond. According to the modeling, again, more inelastic demand and supply will result in higher price effect. This should not surprise us. And if studies that focused on the price inflation of 2007 and 2008 resulted in a substantially higher impact on prices. while the effect of biofuel in the US, now we're moving, that was the commodity prices. That was when we looked at corn for the farmer, the price that the farmers see when they sell it as a commodity. But what happened to the final price, the price to the consumers? What the literature basically told us that corn basically impact around 1% the consumer price index in the US, 3% if we focused on dairy and meat. Not only dairy, also meat. The economy responds to prices. It alters inventories, it alters investments. Very important, and Harry pointed it out, dynamics of the system matter and matter a lot. And this is a big challenge because from the literature that we read, most of them are static or kind of introducing dynamics, but in a very primitive way. Dynamics are very important here. The literature suggested adjustment to short-run shocks, and rural communities did benefit. So if the literature that tried to analyze across the globe in many developing countries as well as others, rural communities did benefit from the introduction of ethanol in locally, but again, the challenge is assessing the benefit and cost over time. Again, the dynamic component, we kept on seeing it as we read the papers, is not complete, and we think it's a big challenge, or it's an important thing to introduce. We went then to the third factor that we want to understand what the literature is telling us. This is fuel prices. Fuel prices declined a few percent point because of the introduction of biofuels. Oil, the sample again is very thin in terms of the literature, so there's not a lot of place for statistical analysis. When we look at it, however, there's no change over time. It's around 4.5% point. What the modeling and comparing the various papers told us, refineries respond, but again, their response is limited. They cannot eliminate it, the price changes, as some have argued, but they can alleviate it substantially. And again, modeling matters. The more richer the system that you model, when you calculate the impacts, the lower will the price fluctuation be, because markets respond, they adjust. Again, this is just interpreting the literature, interpreting the results. But, then we went to economic surpluses. So we looked at prices, we looked at greenhouse gases, we didn't see really a substantial effect. So the question is, what is the big driver for policy? Why did we see the US energy policy in 05 and 07, then they revised? What might be the motivation for it, assuming that this is capturing what the politicians are interested in seeing? So we went to the economics, and we wanted to look at the economic surplus. The median was around 0% when we compare all countries. US and Brazil was slightly positive on average. Some models employed a computation general equilibrium models, other were a multi-market. Again, much of the analysis was static, and that's again something we find a bit problematic. When we looked at the regression analysis, models that employ computation general equilibrium approach result in corn ethanol yielding more benefit to the US than otherwise, an average in the order of magnitude of 3 billion. Models that introduce other countries, introducing trade, result again in an increase in benefit. In this case, it was around 5.5 billion. Again, economic assumptions matter very much when you calculate the impacts, and the richer your environment, in this case, when you want to know the economic benefits of the introduction of biofuel, becomes larger. However, this is just a side looking at learning by doing. There is a lot of learning. There is, however, some concern regarding these numbers, in part because there's simple calculation based on capacity of production, and Madhukana has a very nice paper criticizing or pointing out to the problems of doing these estimates, in part because you're not accounting for changes in prices and in markets and market power and so forth. But again, from what we look, taking the literature on face value, we do see learning. So this whole exercise was done in order to try to understand what was the big driver behind the US energy policy. What caused the politicians to make decisions that promoted the 2005 Energy Act and then later revised it in 07? Just taking the reveal preference approach, that what we see, the outcomes are basically what the politician wanted to see. We found out that this is very important. There are two parameters that turn out to be very, very significant when we looked at biofuel. One of them was employment. The other one was the balance of trade. Balance of trade can be translated to impact on the manufacturing sector domestically. And these macro effects seems to be important and substantial, and they seem to be an important component in the outcomes of the policy. Whereas if you take the reveal preference approach, that means that this is the main driver and a very important driver to politicians. While focusing on US policy, it's the same thing for coal. It's the same thing for petroleum, and it's the same thing for natural gas. So biofuel is not unique here. It's not someone identified. It's simply that's the way the US policy is driven. Again, if you believe the reveal preference approach, and if you believe the results that we're getting from all these papers. The big impact was in terms of the balance of trade. Just to bring you some numbers, in 2005, US consumed 3.3 billion barrels of gasoline annually. 2011, that dropped to 3.2. That's a decline of 4%. Ethanol is equivalent to 2/3 of that amount. On the other hand, if you look at production during the same period, production of gasoline domestically increased 9%. This simple rough calculation will give us a change of around $50 billion. This is 8% of the US trade deficit. These numbers are not insignificant. And we have a quote actually that from the Obama administration in 2000, if I remember correctly, 10 or 11 saying exactly that. The balance of trade is an important component, and trade balance is something, a big driver there in the policy. So just to conclude, in the interest of time, not to dwell too much, what we did, we basically wanted to look at the literature. We wanted to look at the literature, apply the reveal preference approach, and said, given that we do believe in a reveal preference approach going all the way to McFadden, what does that tell us about the politicians? And what we learned from the analysis, by looking at the literature and trying to systematically decipher and understand what it means statistically, the big impact of biofuel was on the macro variables. It was on the balance of trade, it was on employment. It was the impact on rural development and agriculture states. Biofuel policy was the corn ethanol policy was very similar to the oil, natural gas, and coal policy. It wasn't significant. So this is an important driver, we believe, when we look at US policy. Now, it's not unique also to the US, because I can give you other papers that will argue similar statements when you move to other countries in the world. Energy security is very important. And our takeout from this analysis is that whenever you want to create an energy policy, you can care a lot about the environment. And that might be at the heart of all of your arguments. The big driver will be, and needs to be, in terms of the politician, is energy security. As far as we understand from this, just trying to interpret it. And that's our take-home message from this. And this is what we saw based on this analysis. Macro level aggregate considerations are key to energy decisions, and we have supported it both from other literature talking about energy security as well as by the statistical analysis that we did on corn ethanol. I tried doing it fast.